Okay, here's a new article. We're in the same area here recently with a video talking about Krakatoa and its effects. And pretty much the lower map is the area that it would just directly affect whenever it went off. But of course, we figured that it affects around the world. In fact, that had to do with the Justinian plague. And now that we're starting to figure out certain dates for things happening, it's showing that volcanoes even have an incredible effect on the planet, much less something like a cometary impact or whatever meteors or whatever happened at the end of the Younger Dryas event and what could have caused its catastrophes. Evidence of late Pleistocene human colonization of isolated islands beyond the Wallace line. Now, the Wallace line is a line cut through here, and we were talking about Bali, that's right there, and this is Java and then Sumatra, and in between there in that little pinch is where we find Krakatoa. And in the map that they're showing here, it shows land above 130 meters. So at the last ice age, that there would have been a lot more land exposed. In fact, pretty much Australia connect almost totally to Papua New Guinea and around through here, and I believe that most maps show this connects a little bit better than it does there, other than just a couple of dots. Also Sulawesi Islands, and so there's little bitty gaps that only if you can make that gap that you could make it all the way down into Australia. And this is the idea of how the Australians had gotten down there in the first place, and at the last ice age some 50,000 years ago. Now the equator runs through just basically right here. So this is just below the equator going across here. And there's Sulawesi. So this is area that they refer to as Timor-Leste, and in a close-up of it, we're seeing it here. Here's Isle of Flores that had the Hobbits on it. So keep that in mind as they talk about them here later. But here we have these two sites that are on Alor Island, and then in the longer island here of Timor, there are two other sites. And they've been looking at this, and what the Wallace line really declamates is that there is Australian flora and fauna, and there is Asian flora and fauna, and then there are Indonesian mixes, and some of the plants and animals make it all the way up to here and then stop. And I've told you in the other video how it's weird that certain fish species seem to go with this too and have a declamation of being on that side or this side, and they refer to them as Red Sea variants and things like that that goes on. But I've always thought this circle right here, if we'll look at that right there, it kind of circles the A, like I would be right in the middle of it here. It's not that much bigger than what mine is. Would be a crater type mark, but earliest things that we can think of is they say these are a volcanic set of islands set up much like Hawaii is in some way. But I wonder if anybody's done any other investigation for if they ever drilled for oil like they did in Yucatan, they might come up with a different idea, and no telling what the age on that would be and what epoch of the dinosaurs or whatever we would find that it goes along with. And way off to the right up here is going to be up Hawaii and so on. Australia is down at the bottom. So that's where we're looking at when we talk about this. A new article published in Nature Communications applies to stable isotope analysis to a collection of fossilized human teeth from the islands of Timor and Elor in the Wallacea, that's the area they speak of, to study the ecological adaptations of earliest members of our species to reach this isolated part of the world. Because the Wallacean Islands are considered extreme, resource-poor settings, archaeologists believe that early seafaring populations would have moved rapidly through this region without establishing permanent communities. Nevertheless, this has so far been difficult to test, so they haven't seen very much and really done that much archaeology, unless somebody finds something in this area. The study, led by scientists from the Department of Archaeology, Max Planck Institute for the Science of Human History, MPI, alongside colleagues from the Australian National University and universities of Gadjah and Magda, used an isotopic methodology that reveals the resources consumed by humans during the period of tooth formation. And this is the test that they've done, and they can do a strontium type test and tell you like the water, and by that they can almost tell where the person came from. There was this study that's famous about it where they can tell that some people that were up there right around Stonehenge had come from far, far away to do this, hundreds of miles at least. And because they had known some people that fit that strontium number, and it looks like, well, they grew up here and they ended up there, and some migratory type things. And then people were moving around a bunch more. I made a mention in that story there that somehow in our minds we got an idea that people were on little dots and under little pins, and Caucasians somehow were just right here and stuff, or this and that. It's like, that's not the way that was at all. You're not paying attention. But also, people from over here and here are finding all kinds of connections. In fact, I show back before history where there are connections with such things as Venus statues and symbology like swastikas and all that goes back. But here we are going somewhat a little bit deeper. So they demonstrate that the earliest human fossils so far found in the region, dating to around 42 to 39,000 years ago, so well into the last ice age, they relied upon coastal resources for their foods. Yet from around 20,000 years ago, humans show an increasing reliance on tropical forest environments away from the island coasts. The results support the idea that one distinguishing characteristic of Homo sapiens is high ecological flexibility, especially when compared to other hominids known from the same regions. So basically, they seem to be able to overcome just about anywhere except for the tallest mountains. And there's something I believe in this article or the other one I was looking at that speaks of Denisovans, and how some people feel that genetics that they get helps them to breathe in oxygen in lower environments, and then you get these mixes and stuff. But over the last 2 decades, archaeological evidence from deserts, high altitude settings, tropical rainforest, and maritime habits seem to increasingly suggest that late Pleistocene humans rapidly adapted to a number of extreme environments and extreme changes. By contrast, our closest hominid relatives such as Homo erectus and Neanderthals apparently use various mixtures of forest and grasslands, albeit as far apart as the Levant, Siberia, and Java. But however, this apparent distinction needs testing, especially as finds of another closely related hominid, the Denisovans, have been found on the high altitude of the Tibetan Plateau. So people that live up in the Himalayas and so on. And it's looking like drastic changes that were going on even through the last ice age, maybe from something that happened 18,000 years ago, for there seems to be another strike then, and that's recorded in that little wiggle, that might have caused something, and or volcanoes gone off or whatever, and this is not out of the area at all. And so things like that might have caused changes, but it could have caused changes across this whole grass and plain lands. And those early hominid relatives like Homo erectus and Neanderthals seem to peter out. There was a paper here recently, just a couple of years ago, that was talking about how Homo erectus had died out from basically being lazy, that they were just using easiest forms and methods, and then when the big thing hit, they couldn't handle it. Whereas it looked like a lot of the others did, and they're only left behind as remnants now, or were in ancient times up until recently. Apparently used various mixtures of forest and grasslands, so as far apart as Levant, Siberia, and Java, so quite distinctive after a while. So these are some fish hooks that they found, and these were made out of shells, so clams and mollusks and stuff, and then they had been carved to the point of making a shell out of them. And if you look at this edging right here, you can see it gets skinnier and point. There doesn't seem to be a jagged point sticking out here that you would think of, but just short of that, this reminds one of that hook that you see in Moana, that Maui in Their mythology said he hooked it onto a rock and, in trying desperately to pull it up, ended up pulling up the mountains, which are really the islands themselves in their story. That it's at the site of Lean-Hara, so the far right ones of the ones we're looking at, and it's dating to 11,000 years ago. As one of the and it says an earlier, less complete version. So, as one of the corresponding authors of the new paper, Sue O'Connor of Australian National University, says the islands beyond Wallace's line are ideal places to test the adaptive differences between our species and other hominids. These islands were never connected to the mainland, Southeast Asia, during the last Pleistocene, and would have ensured that hominids had to make water crossings to reach it. In other words, any finds that we find of that dating have to say that they were able to use boating, rafting of some form in nature to be able to make it across to those points. Whether it even is something that you can see in the distance, like between the rocks of Gibraltar, it's not a real swimmable thing. So you have to have something that's going to get you to that point, basically. And so whenever they say the Australians are there some 50,000 years ago, but it may be as much as 65,000 years ago, it's because they find remnants of something and they can't find a hominid, but they know people were here and doing things, and it relates to a time that was that long ago. And again, this is during the time where everybody on Earth was crammed down towards the middle. It's another issue that people don't usually think about, it seems to me. When we should get back to a certain point, breaking 10,000 BC, everybody was squished down. Vikings weren't where they are. Things were very different in a different world. Almost a different world. In fact, it was. In a time of hobbits and short people, some tall people. So the short people would call the tall people giants. The giants would call the short people hobbits. And wee people, and so on, and went on there, and it gets exaggerated, stereotypical, and things. And then lo and behold, how we have the seven dwarfs and all the D&D type things, and the fairies and all the situation that comes out of it. But that's neither here nor there. Let's go on. Tropical forest settings like those in Wallacea are often considered barriers to human expansion and are a far cry from the sweeping savannas with an abundance of medium to large animals that hominids are believed to rely upon. So it entails, it's a different environment. For just Sumatra, we were looking up there, it's got tigers on it. There are tigers in Bali itself. But there seems to be a barrier there, and tigers are known to swim, but there's a point to that, just like people are known to swim. And people have swum the English Channel and but this is far-reaching beyond that, and it starts to get oceanic. Fossils and stone tools show that hominids made it to Wallacean Islands at least 1 million years ago, including the famous Hobbit, or Homo florensis, we talked about recently. And now they found another one there also, too. So there's this correlating data thing, and that's whenever I did the video on it a year and a half ago. When our own species arrived 45,000 years ago, or perhaps earlier, it is thought to have quickly developed the specialized use of marine habits, as evidenced by one of the world's earliest fishhooks found in the region. Nevertheless, as co-author Sari Shipton puts it, the extent of this maritime adaptation has remained hotly debated and difficult to test using snapshots based on often poorly preserved animal remains. And nothing like a built fish net that was a little finer than a regular net for like an animal or whatever could have been used back then too, but there would be nothing found of some remnant like that. It would have a difficult time being preserved, and the jungle environments there don't seem to preserve things as well as stuff like peat bogs and little mud flows of alkaline material that go over something and you case it and stay like that. For the acidity, it eats up the calcium of the bones and so on, and it doesn't do a good transfer, even if it does when it becomes fossilized. Stable isotope analysis and late Pleistocene humans. This paper uses stable carbon isotopes measured from fossil human teeth to directly reconstruct the long-term diets of past populations. Although this method has been used to study the diets and environments of African hominins for nearly half a century, it has thus far been scarcely applied to the earliest members of our own species expanding within and beyond Africa. And we need to do a lot more of that testing. Using the principle, you are what you eat, researchers analyzed powdered hominin teeth enamel from 26 individuals dated between 42 and just 1,000 years ago, it says, and explore the types of resources they consumed during tooth formation. Here's one of the digs that's there, and you can see that they've dug in the pit, and it appears in this one area in the front of the cave here, for a long period, people were building fires and things. There appears to be ash layers that are just cut back and forth, and even some stones that are around the edges here in places that might have been a hearth about this size or something that they found earlier. I'm not sure. There's not a detail about this, but there is a paper at the end of this that talks about things, and it seems strange. There's a little line that's here in it, and then wonder what you'd find if you dug all back in there to the depth that you've done in here. The new paper shows that the earliest human fossils available in the region, excavated from the site at Asatau Kuru on Timor, was indeed reliant on maritime resources, suggesting a well-tuned adaptation to the colonization of coastal areas. This fits with our existing models of rapid human movement through Wallacea on the way to Australia, says co-author Shimona Keeley of the Australian National University. One thing though, we were looking at that map earlier and it showed all those darker areas, and you know the coastline just grows like hell around everywhere pretty much unless there's a drop off. And so if they really were coastal, all those areas would be pretty much underwater. And in fact, in reality, these sites that they're finding, which are looking to be at 49,000 years ago ability old during glacial maximum, lowest water levels, would have not been a coastal habitat. And this might even show you that these people were doing both, but they had people that were doing a lot of fishing and bringing it all the way up to there. For what you think is pretty much coastal now was 160 meters from the ground, and in some of those areas that could carry kilometers inland from where they were. In fact, some of these cases, these people could have gone from the ocean kilometers inland into a river coming out of an area and ditched it, and that's the area now that you seem to consider was coastline, but it's not really, or it wasn't then. But then from around 20,000 years ago, which is still coming out of glacial maximum, however, human diets seem to have switched inland towards the supposedly impoverished resources of the island forests. Some individuals maintain the use of coastal habitats, the majority seeming to be adapt to the populations of small mammals and tropical forest plants in the region. As co-author Maherta Universitas Gahida Mata puts it, coastal resources such as shellfish and reef fish are easy to exploit and available year-round, However, growing populations likely forced early island occupants to look inland to other resources. And I bet they were kind of doing that anyhow, but again, they probably weren't going that far. And even 20,000 years ago, if they see them coming farther inland, this to me just shows that they found a bunch more people that are closer to what would have been the ancient coast, and later ones that have even gone farther. So this might say instead of island hopping around like in Moana, they reached a point and stopped, and then there was much more exploration. Whether they went across the entire island 3 or 4 or 5 different times before this thing happens that they're finding, once they're finding these 20,000 year age, it looks like people were definitely going through that resource finding and stuff that goes on. So, a species defined by flexibility. This study provides the first direct insights into adaptations of our own species as it settled in a series of challenging island environments in Wallacea. Early human populations here and elsewhere could not only successfully use the enormous variety of often extreme Pleistocene environments, suggests Patrick Roberts, lead author of the study group and leader at the MPI. They should also specialize in them over substantial periods of time. As a result, even if some local populations did fail, the species as a whole would go on to become a tremendously prolific species, i.e. the islanders got it all going on and stuff, and we know that. And here we go again with the Moana type things and stuff. But from some people that who knows where headhunters come into that and all that type of thing, back and forth through it, but eventually through it all, they did populate out of it, and it would be hard to track back and forth and see what happened everywhere. You'd have to have some type of Star Trek scanner and be able to look through and see basically every skeletal structure thing that there is and be able to analyze it like Spock through a thing or something like that. And I think we're a far cry from that. In fact, by the time we get to that point, whatever is left in some fragments now is probably starting to really disintegrate away to almost nothing, and we probably wouldn't have the ability to analyze it to the point of even telling what it was before that point. One would doubt it. So we're on a race in many ways to save our possible archaeology and be able to dig through that and peer through the veil of where we were before versus the narrative we've been told. As dense tropical rainforest replaced mixed grasses and woodlands, other hominins in Southeast Asia went extinct. Ecological flexibility, supported by the unique technologies and the capacity for social relationships and symbolism, seem to have carried Homo sapiens through the climatic fluctuations of the late Pleistocene, however. So, whenever we look at those groups of people, they seem to have all the symbology and things going on, and it seemed to carry people through, and maybe some of these others that later you see having similar symbology. And that's a good attachment point for one of our little webs here. But notice that in these fluctuations going on that they talk about, that this middle area of Earth, equatorial, as it turned into dense tropical forest, it replaced mixed grass woodlands, and then as the frost melted away from the middle area, a lot of other areas became those open lands and so on. And so there must be adaptation, migration, movements, all kinds of things, and in the possibility of making it through that, it seems we came up with even more possibilities and ways of doing things that made it to where we were successful through all the other forms that we went through. And even though we've had these hominids And these, not too long ago, Neanderthals, the last of Homo erectus, Denisovans, and so on, it's kind of neat how we came out the end of that, and we're looking back now trying to figure it all out. And that's what seems strange. I think that and the fact that the moon and the sun are the same size in respect to our eyes has probably set this planet off on more of an odd concept than one would believe. For if it had a dual sun thing, like, oh, I don't know, in Star Trek or something, probably would have figured out the relationships of things a whole lot easier in some way than what we did, and our symbolism might be a lot different in the way we looked at things. And I'll show you a lot of that in the upcoming series that I have going on, but let me get through some of these that need to be done. The authors concede that more work is needed to conclusively test the ecological distinction between hominid species. The discovery of Denisovan populations in the tropical environments of Asia, our application of this isotopic approach to other hominids in the tropics, would yet show Homo sapiens to be less exceptional, perhaps. Nonetheless, for the time being, it seems that it was our species that could do best adapt to the variety of environments across the face of the planet, leaving it, by the end of the Pleistocene, as the last hominin standing. And that's where we currently are. Interesting studies, and I always try to look in these, and it gives me a little breadth of study and concepts and ways to think about things whenever you try to look at whole pictures and concepts of it. And I could go on and on about fish in this area and how these cryptic species live in here, mimic octopus that mimic other fish that are poisonous, and they know what the fish don't like them, and they mimic the thing that they don't like. Whenever they come up to mess with them in any way, they're like, oh, I'm a lionfish. It's wicked. Hopefully some of you have seen that. Anyhow, on to the next story, and because this was closely related to Sumatra and the area that's in here and ties together a couple of things that we were talking about before, I thought I'd hit on it again. Like, share, and subscribe, and enjoy. Comment down below. Peace.